Hey, discrete math students, this is Miss Hamilton. Welcome to day one. We're going to talk about probability today. In this video, we're going to do some refreshers on some stuff that we talked about in our probability unit, and then we're going to do a couple of examples. I would encourage you guys, if you don't already have some paper and pencil, to pause the video and go grab some so you can take notes. And then once you finish this video, I encourage you to go to the day one Google form and try to complete some of those practice questions. As soon as you submit them, you'll get some feedback as to whether or not they were right or wrong. And then for anything you got wrong, there will be some kind of helpful hints to let you go back and fix your work. So let's get started. The first thing I want to remind you guys of is just what is probability. So if I ask you to find the probability of an event, I'm looking for the number of ways that event can occur over the total number of outcomes. So for example, if I was asking what's the probability of rolling an even number on a dice, there are a total of 6 outcomes and 3 of those are even, so 3 out of 6 or 1/2 would be my probability of rolling an even number. And then a lot of times questions ask about the sample space. So the sample space is just the list of all of the outcomes that could happen. So in the probability, we use that number. When they're asking you for the sample space, they're generally asking you to actually list out every single thing that could happen. So for the dice roll, our sample space would be 1, 2, 3, 4, 5, 6, because those are the numbers on the dice. All right, let's do an example with sample space. So example 1 says a person shoots 10 consecutive free throws and the total number of successes is observed. How many different outcomes are there in the sample space? So this one is not asking us to list the sample space. It's asking how many outcomes are there in the sample space. So we know that this person is going to shoot 10 free throws. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. And then each free throw, they have 2 options. They can either hit or miss. We don't know what's going to happen each time, and each time is kind of independent of the next track. So the total number of successes that we're going to observe, there are 2 options. So 2 here, 2 here, 2 here, 2 here, 2 here, so on and so forth. This would tell us how many total ways there are for them to make or miss any combination of shots. And then we are able to look at that and then see how many of them they actually made. So I had 2 multiplied by itself 10 times, so 2 to the 10th power are how many outcomes there are in the sample space. And we don't have to list them all. That would take forever. So we just need to know that number. If you guys have any questions about this first part, the example, or the notes before it, there is a place in our collaboration document for you to type those questions in, and then your classmates or I can answer those, and that's kind of a place where everybody can see that question. All right, let's look at our next thing. So the next thing we talked about in our probability unit were permutations and combinations. And remember, for permutations, these were things where order matters. So this was things like passwords where, the password ABC is different than the password BAC. Combinations is where order does not matter. So this would be something like if you were choosing, your cookout tray, the 2 sides that you chose, it doesn't matter what order they're in, it just matters which sides you chose. So hush puppies and a corn dog is the same thing as a corn dog and hush puppies. When we knew what kind of permutation or combination we were using, then to calculate those, remember, we could either use that calculator feature NPR, or we could remember that it's n factorial. So n is your total number of things you're choosing from. So like a lot of times we're talking about like the alphabet, so n would be 26, or the number of cards that you're using, so 52. divided by n minus r. and R are the number of things that you want to select. So if I was choosing from the entire alphabet and I wanted to select 3 letters to make a password, R would be 3 and N would be 26. Then for combinations, it's NCR, so you can use that shortcut in your calculator, or it's N factorial over R factorial times N minus R factorial. So this essentially is the exact same thing as your permutation one, except we're dividing out the repetitions. So this is kind of taking into account the fact that ABC and BAC would be the same thing if we were talking about a combination. All right, let's look at an example of each. So example 2 is a computer password consists of 5 capital letters from the ordinary English alphabet, A through Z. How many different passwords start with the letter Z and end with the letter W? So a password, we are definitely talking about a permutation because the order matters. But in this case, we are able to use the same letter multiple times. They're just giving us specifics about the first and the last letters. So we know that there are supposed to be 5 letters, 1, 2, 3, 4, 5. The first letter is supposed to be a Z, and the last letter is supposed to be a W. So if we think about our number of options, there's only one option for each of these. We have to choose a Z, we have to choose a W. Then in the middle, we can choose any other letter. They don't give us any restrictions. So there are 26 letters in the alphabet, so each of these choices is 26. So we end up with A, 26 to the 3rd power. I do want to talk about really quickly about how this question could be worded differently so that you would be using that permutation feature. That would be if you were not allowed to repeat letters. So if they said you can't repeat letters, then this problem would change slightly. We would still only have one option for Z and W. And since we can't repeat letters, now there are only 24 options here, and then only 23 options here, and then 22 options here. So these 3 letters here, I am taking 24 letters of the alphabet and permuting 3 of them, which means I'm ordering 3 of them. So you could use this to calculate the same thing as 24 times 23 times 22. So that's kind of where the permutation part of this could come into play. All right. Example 3. In a certain state's lottery, 48 balls numbered 1 through 48 are placed in a machine and 6 of them are drawn at random. If the 6 numbers drawn match the number that a player has chosen, the player wins $1 million. In this lottery, the order the numbers are drawn in doesn't matter. So that is really important. Compute the probability that you win the $1 million prize if you purchase a single lottery ticket. All right, so the fact that the order doesn't matter means that as long as you get those 6 numbers, it doesn't matter if your choices were in the same order as the state's choices. So what we are thinking about when we're trying to find the probability of you winning, we want to think about how many total ways are there for 6 numbers to be drawn, and then how many ways are there for you to draw those 6 numbers, so you to pick the right one. So there are 48 total balls, and since we know the order doesn't matter, that's going to be a combination, and we're choosing 6 of them. The only way that we can win is by, from those 6 numbers that are chosen by the state, we have to choose all 6 of them. We kind of know that the only way to do that is there's just one option. So this top number is just 1, and then the bottom number you could calculate using your calculator, but that's kind of how that probability part works. All right, so once again, if you have any questions about this section on permutations and combinations, please put those in the collaboration document. Your classmates and I will be happy to answer them. All right, sorry. Last piece, probability space. So we touched on this just a little bit in class, but these are kind of some of the types of questions that you could see talking about probability space. A probability space is essentially saying, okay, so for all your events, all your simple events, what are the probabilities of those? So if we go back to that like dice rolling, a probability space for a dice would be like the probability of rolling a 1 is 1 out of 6. The probability of rolling a 2, 1 out of 6. The probability of rolling a 3 is 1 out of 6, so on and so forth. And the key thing that we need to remember about probability spaces is that the sum of all the probabilities is always going to equal 1, because that's going to show us like what 100% of our options are. So when we're asked questions about the probability space, this is going to be a really key part of that, is knowing that they always sum to 1. So with that in mind, let's try an example. So it says, consider the sample space, 01, 02. These are just like the options or the outcomes that you could get. So outcome 1, outcome 2, outcome 3, outcome 4. Suppose that you are given that outcome 2 is 3 times as likely as outcome 1, that outcome 3 is 3 times as likely as outcome 2, and outcome 4 is 3 times as likely as outcome 3. And we're trying to find the probability of outcome 1. So if we start outcome 1, I don't know why I made that a Q, sorry. So outcome 1 is equal to, we don't know, so we're going to call that X. But we do know that outcome 2 is equal to 3 times outcome 1, so 3X. Then outcome 3 is equal to 3 times outcome 2. So 3 times outcome 2, which was 3X, or 9X. And then finally, outcome 4 is 3 times as likely as outcome 3. So, outcome 3 was 9X, so 3 times that, we get 27X. All right, so this was just some algebra part. Now the part that we need to know about probability space is the probabilities of all these guys add up to give us 1. So the probability of outcome 1 plus the probability of outcome 2 plus the probability of outcome 3 plus the probability of outcome 4 has to equal 1. So now we're just going to substitute in what we know. So we know that the probability of outcome 1 we're calling X, probability of outcome 2 we're calling 3X, 9X, and 27X. If we combine our like terms, we get 40X equals 1. So then we divide by 40. Sorry, I'm running out of space. And we get X equals 1 out of 40, which tells us that we're looking at answer choice B. So we can give you lots of different ways that this problem can be set up. I just wanted to show you that the main feature is that we have to know that it's equal to 1. All right, y'all, that was our last example. So once again, any questions that you have, type those in the collaboration document. I would encourage you guys now to go to your Google form, try those practice problems, submit those so that you can see if you're getting them right or wrong and get some feedback on the ones that you're getting wrong. There are also spaces in the collaboration document for questions on any of those Google form questions that both your classmates and I will be checking in to answer. All right, I hope you guys are all doing well, and I will talk to you tomorrow.